お待たせいたしました。これより、メドピアトラックでは、Vue コアチームメンバー、クリエイター of Vue Vapor ケビン・デン様によるセッション、Vue Vapor Reinvention をお届けします。本セッションでは AI 英語教材 ABC を開発、個人の可能性を最大化する株式会社グロービー様の提供により、英語から日本語へ同時通訳をご利用いただけます。ご希望の方はお席に置いてある受信機をお使いください。なお、受信機はセッションが終了したら本トラックの外には持ち出さず、そのまま席に置いてくださるようお願いいたします。また、Vue Fes Japan 2024では4つのトラックを同時進行しています。このメドピアトラックでは、ハッシュタグ Vue Fes _ メドピアでどんどん感想を共有してください。Mr. Deng, are you ready? それでは皆様、どうぞ温かい拍手でお迎えください。
Hello, everyone. It's my first time to have an English talk, so I'm very excited to be here at Vue Fes Japan and meet all of you. First, let me say hi in Japanese as well. 皆さん、おはようございます。こんにちは。はじめまして。よろしくお願いします。今日のプレゼンテーションのテーマは Vue Vapor 再発明です。Okay, today we will talking about Vue Vapor reinvention. In this talk, I will go into explore Vue without the virtual DOM. Some of this might be a little technical, but I promise there are fun parts too. All right, let me introduce myself first. I'm the author of Vue Vapor and Vue Macros Elk. I'm also a core team member of Vue, Vueuse, and AnJS. Plus, involved with unplugging and Vite and OXC. If you are interested in my activities, you can find me on GitHub and Twitter. I joined Vue team member 2 years ago and might be the youngest core team member. Now, I essentially maintain projects within the Vue and unplugging ecosystem, and also work on some front-end tool chains. All right, let's dive into the main content. First, let's do a quick poll. Here is a QR code, and feel free to scan it. Cast your vote. How many of you have heard of Vue Vapor before, and how many of you have tried building a demo or even contributed to Vapor? Here is the result to display it in real time. So you can see how many people are familiar with Vue Vapor. Wow. That's good, right? We have 2 contributors and 5 users. Yeah, pretty good. And some of you might be wondering, why is it called Vue Vapor? Because we hope Vapor can be lighter, faster, and more flexible, just like Deng, right? This picture is very good. It carries symbolic meaning. Of course, the inspiration of Vue Vapor comes from Vue Solid.js. We hope Vapor can be the Vue version of Solid. So, what exactly is Vue Vapor? Vue Vapor introduces a new rendering mechanism. So, what are the key features and what goals we are aiming to achieve? First, it no longer relies on the virtual DOM. Instead, it directly calls the native DOM API. And second, this reduces lots of overhead, improves performance, and reduces the less memory. It also reduces bundle size. by using the native DOM API directly, we removed code for virtual DOM, no stiff, and fine-grained rendering. Based on Vue reactivity system, we can precisely checking the data changes and updating what only what's to be needs to be updated, instead of re-rendering the whole component and find the change of VDOM nodes. So these are the goals we aiming to achieve with Vue Vapor. As I said before, Vapor can reduce the bundle size, right? But how much? Currently, it decreased by 53.3% compared to VDOM mode. This figure compares the rendering logic of Vapor to VDOM mode, excluding reactivity system code. Let's dive into how Vapor stacks up against other frameworks in terms of performance. First, we have Vanilla.js, which is gold standard for speed. And Solid.js comes very close with impressive performance. Svelte also delivers exceptional speed. Now, Vue Vapor is on par with Svelte, as Evan said before, which is quite impressive. It's noticeably faster than Vue VDOM mode and React with Jotai. Even though Vapor already surpasses VDOM and React, there's still room for improvement, and we are dedicated to making it even better. So Vapor has so many improvements, where Vapor has breaking changes compared to the virtual DOM. Not exactly. Vapor aims to be a subset of VDOM mode. First up, the current VDOM mode supports a bunch of features like Options API, Composition API, customer directives, mixings, and more. Now, Vapor is a bit different. It currently supports only the Composition API and doesn't include the Options API. But based on the feedback, we might provide Options API as a third-party library in the future. And Vapor needs a build tool for compilation. So it cannot directly run in the browser with CDN imports. This is because Vapor's compiler is quite complex and relies on toolchains like Babel. Running it in the browser would slow things down and bloat the bundle size, making it even efficient than using VDOM mode. Lastly, Vapor supports script setup only, so you cannot export components within a normal script tag, because script setup is the best practice for the Composition API, and dropping the Options API, the compiler can optimize the code more effectively. Okay, next, let's talk about compatibility plans. Vapor is currently compatible with most of Vue's functions. That is because its reactivity system is fully aligned with the Vue virtual DOM. Aside from some component-related functions, everything else works directly. And Vapor will be compatible with official projects like Vue and Pinia. The next step includes with SSG and VidPress. And in the future, Nux will be supported Vapor as well. We hope community to adapt UI libraries like Naive UI Element Plus and Beautify, the adaptation won't be as difficult as jumping from Vue 2 to Vue 3, since Vapor and the Virtual DOM has the same API for the user-side API. Once Next support Vapor, we can make sure Elk does it too. Elk is a community project and a great example of using Vue and Next together. So, will Vue 2 support Vapor? No, it won't. Since Vue 2 reaches end of life this year, so we are not adding any features to it. How is the progress so far? We have already completed most of foundational features like SFC compilation or built-in directives, lifecycles, and more. It's worth mentioning that the voting app you all just used is implemented by Vapor. And next, we will continue to optimize performance, support SSR and hydration, adapt Vue dev tools, improve the built-in components, and finally support async components. Our roadmap depends on securing enough funding and sponsorship for Vue Vapor. If we receive enough support, we plan to launch with SSG support and alpha releases by end of this year. As I mentioned, Vapor has partial support for Vue DevTools, and big thanks to Vue DevTools team for making that possible. Some people have been asking, will Vapor support JSX? The answer is yes. Actually, JSX is supported in Vapor and will be even better than VDOM mode. You can start using it right now. Huge thanks to Gaofei for his contribution. And in the future, we might integrate JSX support directly into the Vue Vapor's code base. That is possible because Vapor's more flexible compiler architecture, which makes adding JSX support much easier. Next, I will walk you through the principle of Vue Vapor. Don't worry, it feels complex. We will take it step by step. Imagine we are building a basic counter app from scratch. No frameworks, just native DOM APIs. First, we have a div, a title, and a button, and then add them to the body of the page. We define a count variable and add a click event to the button. Every time it's collected, the count is added by 1, and we can call a render function to update the count on the page. That's a basic counter app. Pretty simple, right? Just a bit tedious to write. Now, if we bring in Vue reactivity, we can make counts reactive. All we need to do is swap counts with ref, and the increase function update it with count.value++. But still, we have to manually call the render function to update the page. To automate that, we can use effect function and put the render function inside of it. Now, the render function will automatically trigger whenever the reactive count changes. This demo only has one increase function, but imagine if we have decrease function and more functions, we'd have to worry about calling a render function each time, and which is get messy, right? Also, blindly re-rendering everything will slow things down, about performance. So with reactivity, we don't need to worry about where updates are needed and forget to manually call the render function. This is the core principle behind Vue Vapor. To sum it up, we use Vue reactivity to check the data changes, and whenever the data changes, the render function will automatically updates only the specific DOM nodes that needs it. When we talk about React, the concept is UI equals FM state, right? Here, both states and UI are snapshots. At a specific moment, when the state changes, the UI snapshot is recreated and compared to the native DOM nodes. In contrast, Vue VDOM operates a bit differently. The UI is still a snapshot, but the state is reactive. When Vue detects a change in the state, it reruns the render function to generate a new UI snapshot, which is somehow similar to React. However, in Vue Vapor, neither the state nor the UI is snapshot anymore. Instead, the render function runs only once, which means there are only one UI object. When state changes, we directly modify the attributes of the DOM nodes. Instead of creating a new one and comparing them, which is more efficient. A snapshot is immutable internally, but in Vapor, the UI object is mutable on the inside, while appearing immutable externally. This is the key difference between Vapor and Virtual DOM model. Next, let's look at an example of Vue SFC compilation. SFC refers to .vue files, and as you can see, it's almost the same thing as VDOM SFC. The main difference is the Vapor attribute added to the script tag, which tells us it's a Vapor component. Now, let's walk through the compiled SFC step by step. First, the template is compiled into individual fragments, and event handling is proxied to the root nodes. This reduces numbers of event listener, which helps the performance. Next, we define the count variable and increase function inside the setup. The last few lines of code handle the core rendering logic. We bind the event handler into the node and use render effect to tracking any data updates. After that, only the code inside of render effect runs whenever updates are needed. So, how is Vapor's architecture flexible? This diagram shows a core logic of an SFC. First, we have a top-level Vite plugin for users, which calls the SFC compiler. And SFC compiler extracts the template tag and passes it to the Vapor compiler, which finally compiles it into JavaScript code. In particular, the internal process is the first, the parse phase, where the content is parsed into a HTML AST. AST is abstract syntax tree, and it enters to transform phase, where the AST is transformed into IR, that is intermediate representation. We will talk more about this later. Finally, the generate phase converts IR into JavaScript code, which is the final output. So, how do we handle JSX files? First, just with SFC, we have a user-facing plugin. And the plugin calls the core JSX compiler, and the compiler has its own parse and transform phases. But the final generate phase can reuse Vapor's compiler, and this is because IR is both for JSX and SFC that follows the same set of conventions. In addition, Vapor currently supports browsers only, but in the future, they will split into a general purpose runtime and a package specific to DOM APIs, just like VDOM. This will make it easier to support other platforms like native mobile apps. Okay, let's talk about IR. IR stands for intermediate representation, right? So, how does Vapor use IR and what does it do? I would say it's a middleman between the template and the final JavaScript code. It defines some key actions like creating template fragments, binding events, and inserting or appending DOM nodes, setting attributes or properties, and more. This means whatever template syntax is used, as long as it can generate target IR for following the standards of Vapor, we can compile it to Vapor runtime code. The IR can target different template syntaxes, like Vue template, Svelte template, JSX, and more. This makes it easier to support different template syntaxes. All right, let's give it a shot. This is the template explorer for Vue and Svelte. As you can see, the syntax is different, right? In the Vue Vapor, we use if, right? But in the Svelte, we use if block. But as you can see, the final output is almost the same. We have two template fragments, and we use create if API to have to handle if condition, which is the same, right? Thanks to Kazupong for the Svelte template compiler was implemented by him. Pretty cool, right? The power of IR allows us to support different template syntaxes with the same runtime code. Now, some of you might be asking, should I change everything to Vapor at once? The answer is not necessary. Vapor components will be compatible with VDOM mode and vice versa. Of course, it will support a pure Vapor mode. This allows us for a smoother transition without needing to switch everything into Vapor at once. As you can see, we have four circles. The Vapor can be inside of VDOM, and a VDOM can be inside Vapor. And you can migrate critical performance into Vapor first, while keep the other components in Vapor mode. In VDOM mode. Okay. Finally, let's make a brief conclusion. Vapor is a new beginning of Vue, and we are rewriting almost everything from scratch. Vapor is a subset of VDOM modes aiming to simplification. Vapor will continuously optimize the performance and bundle size. Vapor will have a better JSX support. And Vapor will launch SSG, with SSG support and alpha releases by end of this year if funding is provided. I want to take a moment to thank the amazing contributors to Vue Vapor. First, MNU originally crafted the initial runtime of Vapor and remains central to its design and decision making. Then there's me. I'm currently responsible for developing all aspects of Vue Vapor. We also have some fantastic active contributors, Lizumu Ayaka and Ubigi and Dr. Wu. And let's not forget Gaofei for providing the JSX support. Again, I want to give a special thanks to Lizumu Ayaka and Dr. Wu for their help for this representation. The Vue community is incredibly open. Not only does Vapor have so many contributors, but even this presentation had contributors. If you're interested in contributing to Vapor, there's a project you should check out. Reading Vue.js core Vapor is written by Ubigi, and this is a great resource for diving deeper into Vapor's core principle and covering both runtime and compiler aspects. It's available both on English and Japanese. So if that sounds interesting, feel free to explore it on GitHub. Finally, a huge thank you to everyone who sponsored me. Your support is my motivation to keep going. I'm no longer working full-time on Vue, so a sponsorship is crucial for me. To continue developing Vue Vapor, I'm very appreciate any support you can offer. Right now, Vapor cannot proceed without the financial support. If you'd like to sponsor me, you can scan this QR code to do so. Thank you. That's all for today. Kudos for the translators for their incredible work. And thank you all. Enjoy the rest of the talks. ありがとうございます。